our transaction class. Simple syntax for any component is our, at least there should be a build phase and at least there should be a parent handle or something. It is null, and this similar syntax with every component class. And we go to our driver after sequencer. So driver has our transaction as our parameterized with our transaction, and it is also a component. And here we have used our virtual interface because we need to send our data to our interface, then our new constructor and our build phase. So in this build phase, as we have written our syntax to set inside our top module, we will get this our virtual interface from our top module to our driver. So this will get simpler in our UVM. So therefore UVM config DB is there, some storage elements are there. I think 100 entries you can do our handles in our UVM config DB. And connect module connect is not needed here, but I've written you should write in every component if you need to extend something. And finally our run phase, and in run phase, which has started from our top module, then you have seen in our test, then directly in our driver. So here our sequence item port to dot get next item, which we are sending with our transaction to sequence to our sequencer, and in driver we will get this get next item request. So request has our all the transactions, and as our syntax or our SC concept, simple concept is that interface will have this select from our request, then A, B, and Y. All the values we will take from request created in transaction sequence and sequencer to our driver. This request will go to our interface. So we will also go to our interface, and this sequence item then and should be written it is also the part of our UVM environment syntax, that is our sequence item port dot get next item and sequence item port dot item done. So these four things, like these two, and in our in sequence. So this start item and finish item, and our driver sequence item port and our sequence item import, sequence item port get next item and sequence item port item done. These four things are in method used for handshake between our sequencer and driver, and after that all our environment is our completed. So in this way there is our environment. So simple syntaxes are there and nothing complex in our UVM. Just we have to extend our class because it is hierarchy system, and in that some methods are declared. So I will one time run this whole program and I will show you hierarchy and as we have written our topology. So as I said earlier, the tip is simple. Just use this method to create every important and start creating environment. So as I said earlier, you can write every environment class, extended class, register is a component utils or object utils. Then some important terms are your raise object, drop objection, and sequence and driver handling. These two things you should consider. Everything is fine other than that. And this is our final output. You can see the monitor is not there. So after interface, you cannot see the output. After interface, you will get it with our monitor. Then you can see the proper output. So for now, output is 0, and our every other thing is working properly. Our clock signal is not there. I will get the signal. So this is our clock signal. So other than that, all things are working. And as I promised, I will show you hierarchy. So this is our hierarchy. As you can see, as I said earlier, the sequence item port and sequencer has sequence item export, which is already declared in your drive, and these methods are used internally because internal methods are also there in our UVM. So this all methods and all the things are already there, and you can use internally to use everything. So this is our hierarchy. Like top has environment has driver, agent has our driver, and with driver there is also a sequencer. So this simple statement is there. You can add a monitor and coverage and everything you need in your environment. You want 2 driver, you can add 2 driver. Anything is fine. Don't be limited with only a simple architecture.